Across the grasslands of Qinghai and Inner Mongolia, something strange kept happening every spring. Ranchers would wake up to find entire hillsides collapsing, their sheep breaking legs in unseen holes, their grass disappearing acre by acre, as if the ground itself was being eaten from below. It wasn't a drought, it wasn't a disease. It was rats, tens of millions of them, burrowing through some of the most important pasture land in China, and for decades, nobody could find a way to stop them. Poison didn't work, traps didn't work, bulldozing their tunnels didn't work. So China tried something nobody expected. Instead of fighting the rats from the ground, they brought in an enemy from the sky. A predator so effective that entire ecosystems started shifting because of it. This is the story of how a bird became one of the most important tools in Chinese land management, and how a problem that seemed impossible to solve got fixed by doing almost nothing at all. To understand why this mattered so much, you have to understand what these grasslands actually are. The Qinghai-Tibet Plateau and the steppes of Inner Mongolia aren't just empty stretches of land. They're some of the largest natural grazing regions on the planet, feeding millions of livestock and supporting entire communities of herders whose families have lived off this land for generations. These grasslands also act like a giant sponge, holding water that feeds rivers running all the way down into central China. When the grass disappears, it's not just a local problem. It ripples outward into water supply, soil erosion, and the livelihoods of people who have nowhere else to go. These are not small strips of pasture tucked between mountains. We're talking about an area larger than many entire countries, stretching across multiple provinces, sitting at elevations so high that the air itself is thinner, and the growing season for grass is shorter than almost anywhere else on Earth. Grass that grows in these conditions grows slowly, and once it's damaged, it doesn't just bounce back the way grass might in a lush lowland valley. A single bad season of overgrazing or rodent damage here can take years, sometimes over a decade, to fully recover, if it recovers at all. And starting in the late 20th century, the grass started disappearing at an alarming rate. Researchers began noticing something odd. Wide sections of pastureland were turning into patches of bare dirt riddled with holes, like the surface of the moon. At first, people assumed it was just overgrazing, too many animals eating too much grass. But that theory didn't hold up. Even in areas where herders had reduced their flocks, the damage kept spreading. Something else was chewing through the roots of the grass from underneath, and it was doing it faster than anyone could track. The culprit turned out to be a small, unassuming rodent called the plateau pika, along with several species of ground-dwelling voles and rats that thrived in the region's cold, dry climate. These animals dig extensive burrow systems, sometimes stretching for hundreds of meters underground, with dozens of interconnected tunnels and exit holes. A single colony can support thousands of individuals, and because they reproduce quickly, a small population can explode into a full infestation within a couple of breeding seasons. Multiply that across the vast grasslands of western China, and you get a rodent population estimated in the hundreds of millions, all systematically undermining the very ground that livestock depend on. What made the pika such a formidable adversary wasn't just its numbers, it was its lifestyle. Unlike many rodents that live solitary lives and disperse when populations get too dense, pikas are highly social animals that thrive in dense colonies. They don't just tolerate crowding, they seem to benefit from it, with multiple generations sharing burrow systems and cooperating to expand their tunnel networks further and further outward. A colony that starts as a modest handful of burrows can, within a few short years, become a sprawling underground city stretching beneath an entire hillside, completely undetectable from the surface until the ground starts to sink and crumble. The damage wasn't subtle. Where dense, healthy grass once grew, ranchers found their land pockmarked with mounds of loose dirt kicked up from burrowing. The root systems that normally held soil together were being severed underground, which meant that when the region's occasional heavy rains came, there was nothing left to stop erosion. Topsoil that took centuries to form was washing away in a single storm. Areas that had supported grazing animals for generations were turning into what scientists started calling black soil degraded land, essentially the skeleton of what used to be productive grassland, stripped down to dirt and rock. For herders, this wasn't an abstract environmental statistic. It was their entire way of life collapsing under their feet, sometimes literally. Sheep would step into a burrow hole hidden under thin grass cover and snap a leg. Horses would stumble during a run across what looked like solid ground. Families who had grazed the same stretch of pasture for generations were being forced to move their herds further and further, chasing patches of land that hadn't yet been hollowed out. Some regions saw grassland productivity drop by more than half within a couple of decades. There's a human cost buried in those numbers that's easy to overlook if you're only looking at satellite images of degraded land. These herding communities aren't just economic units producing meat and wool for distant markets. Many of them are ethnic Tibetan and Mongolian families whose entire cultural identity is tied to this specific relationship with the land and their animals. When the grassland fails, it's not just a livelihood that's threatened. It's a way of life that's existed in that exact form for centuries. Some families found themselves having to make impossible choices, selling off portions of their herds they couldn't sustain on shrinking pastureland, or relocating to areas already crowded with other displaced herders facing the exact same problem. The Chinese government tried to intervene early on, and their first instinct was the same one most governments reach for when facing a rodent problem: poison. Massive campaigns were launched across the plateau, spreading rodenticide across huge stretches of grassland in an attempt to wipe out the burrowing populations before they could do more damage. And in the short term, it worked. Rodent populations crashed in the areas that were treated, but the poison created a new problem, one that turned out to be even more difficult to manage than the rats themselves. These grasslands aren't just home to rodents, they're home to an entire food chain, including birds of prey, foxes, and other predators that had historically kept rodent populations in check on their own. When the poison spread through the ecosystem, it didn't just kill rats. It killed the animals that ate the rats. Eagles, buzzards, and other raptors that fed on the poisoned rodents were dying in huge numbers, sometimes found dead near their nests after eating contaminated prey. The very predators that could have helped control the rodent population naturally were being wiped out by the chemicals meant to solve the problem. It's worth pausing on just how brutal this secondary poisoning effect actually was. A raptor doesn't need to eat a large dose of poisoned bait directly to die. It just needs to eat several rodents that have already ingested the rodenticide, and the toxin accumulates in the bird's system over time until it becomes lethal. Nesting pairs would sometimes both die within the same season, leaving chicks in the nest to starve, wiping out entire family lines of birds in a single breeding cycle. And here's the part that made the whole approach backfire spectacularly. Rodents breed fast. A population that gets poisoned down to near zero can rebound within a single season if conditions are right, especially with abundant food and few predators left standing to keep numbers in check. So what actually happened across large parts of the grassland was a boom and bust cycle. Poison would crash the rodent population. The predator population would crash right along with it from secondary poisoning, and then with nothing left to hunt them, the rodents would come roaring back even stronger than before. Researchers studying the region found that in some poisoned areas, rodent populations rebounded to levels higher than before the poisoning campaigns had even started. It became clear that killing the rats directly wasn't a sustainable solution. It was treating a symptom while making the underlying disease worse. Chinese ecologists and wildlife officials started asking a different question. Instead of trying to eliminate the rodents through brute force, what if they restored the natural system that used to keep rodent populations in balance in the first place? What if, instead of poisoning the predators along with the prey, they actually brought predators back? That question led researchers to focus on a bird that had quietly been part of these ecosystems for thousands of years, but had been almost entirely wiped out by decades of poisoning and habitat loss. The upland buzzard, along with several species of falcon and owl that hunt rodents as their primary food source. These birds are exactly the kind of predator these grasslands evolved with. A single buzzard can consume dozens of rodents in a week. A breeding pair with chicks in the nest needs even more, sometimes taking down over 100 rodents in a single season just to keep their young fed. Unlike poison, birds of prey are selective. They target live, active rodents, which means they naturally focus their hunting pressure on the areas where rodent populations are highest and most damaging. But there was a problem. After years of poisoning, campaigns had wiped out so many of these birds, and after habitat degradation had destroyed many of the natural perches and nesting sites they needed, the raptor population across these grasslands had collapsed. You can't just decide to bring back a predator that isn't there anymore. So researchers had to get creative about how to reintroduce these birds into an ecosystem that had spent decades pushing them out. The first thing they realized was that these grasslands were missing something incredibly simple: places for birds to perch. In a healthy forest or mixed habitat, raptors have trees, rock outcroppings, and elevated terrain to perch on while they scan for prey below. But on the flat, treeless expanse of the Tibetan Plateau grasslands, there was almost nothing tall enough for a bird to use as a hunting perch. Without a perch, a hunting bird has to expend enormous energy just staying airborne while scanning for prey, which makes hunting far less efficient and less appealing. Researchers realized that even if they could get raptors back into the area, the birds would struggle to actually hunt effectively without some kind of elevated vantage point. Think about the physics of it for a second. A bird of prey hovering in place, scanning the ground below for the flicker of movement that signals a rodent darting between burrows, is burning through energy reserves the entire time it stays airborne. Flight is expensive. A perched bird, by contrast, expends almost no energy while it watches and waits. It can sit motionless for extended stretches, conserving its strength, and then launch into a short, efficient dive the moment it spots something worth chasing. So they built one. Actually, they built thousands of them. Teams began installing simple wooden poles across the grasslands, essentially artificial perches spaced out at intervals across the pastureland. These poles are nothing fancy. Tall wooden posts, sometimes with a small crossbar or platform at the top, planted directly into the ground at regular intervals across huge stretches of grazing land. It sounds almost too simple to work, just sticking poles in the dirt, but the results were staggering. Almost immediately after these poles went up, raptors started using them. Buzzards, kestrels, and other birds of prey that had been mostly absent from these areas began appearing, using the poles as hunting perches to scan the grassland below for rodent activity. From an elevated pole, a raptor can spot a rodent moving through the grass from a significant distance, dive down, and make a kill using a fraction of the energy it would take to hunt from continuous flight. The poles turned previously unusable grassland into prime hunting territory for these birds almost overnight. Local field teams monitoring these installations described watching birds arrive at newly planted poles within days, sometimes within hours, of the poles being set into the ground. Some researchers speculated that raptors from surrounding, less degraded habitat were simply following the availability of hunting perches, expanding their territory into newly pole-equipped grassland the same way any animal expands into newly favorable habitat. Researchers running controlled studies compared sections of grassland with poles installed against control sections without any poles at all. The difference was dramatic. Areas with perches installed saw significantly higher raptor activity and, more importantly, measurably lower rodent burrow density within just a couple of years. In some study areas, rodent burrow counts dropped by well over half in sections where the poles had been installed, compared to areas left untouched. The birds were doing exactly what researchers hoped they would, hunting the rodent population down naturally, continuously, without any of the ecosystem collateral damage that poisoning campaigns had caused. What made this solution so elegant wasn't just that it worked. It was how little it cost compared to previous rodent control methods. Poisoning campaigns required constant reapplication, specialized chemicals, transportation into remote regions, and labor to spread the poison across enormous stretches of terrain, and even then the rodent populations kept rebounding. The perch poles, on the other hand, were essentially a one-time infrastructure cost. Plant the pole, and the birds do the rest, for free, indefinitely, as long as the poles remain standing and the raptor population has a reason to stick around. When researchers actually crunched the numbers comparing the two approaches over a multi-year time frame, the gap in cost-effectiveness wasn't small, it was enormous. Over a 10-year period, the total cost of maintaining a pole network turned out to be a small fraction of what an equivalent poisoning campaign would have cost. And the pole network kept improving in effectiveness over time as raptor populations grew, whereas the poisoning campaigns produced diminishing returns as rodent populations kept rebounding stronger each cycle. This program expanded rapidly once the initial results came in. Provinces across the Tibetan Plateau region and into parts of Inner Mongolia began installing perch poles across huge tracts of degraded grassland. Some installations spanned thousands of poles across single counties, essentially building an artificial infrastructure of hunting perches that turned the entire landscape into raptor-friendly territory. Local wildlife officials started tracking not just rodent burrow density but bird population recovery as a direct metric of program success, and the numbers kept climbing in the right direction. There was another piece to this puzzle that researchers had to solve, though, and it had to do with where these birds actually nest and raise their young. Perches solve the hunting problem, but raptors still need safe nesting sites to breed and maintain a stable population over multiple generations. In a landscape with almost no natural elevated structures, nesting options were extremely limited, which meant that even with plenty of prey and plenty of hunting perches, the raptor population couldn't easily grow beyond a certain point without safe places to raise chicks. So, alongside the hunting poles, researchers and local conservation teams began installing artificial nesting platforms in select areas, essentially elevated boxes or platform structures mounted on sturdier poles, specifically designed to give raptors somewhere safe to build nests and raise young away from ground predators and human disturbance. These nesting platforms became critical breeding sites, and over successive seasons, biologists documented raptors successfully using these artificial structures to raise multiple broods of chicks that then went on to expand the hunting range even further as they matured and established their own territories nearby. Building these nesting platforms required a slightly different level of engineering than the simple hunting poles. The platforms needed to be sturdy enough to withstand fierce plateau winds that can gust well over 60 kilometers an hour during storm season, and they needed to be positioned carefully to avoid excessive sun exposure that could overheat eggs and chicks during the hottest parts of the day. Teams monitoring these nest sites over multiple breeding seasons documented steadily increasing fledgling survival rates, as the designs were refined based on what worked and what didn't in the field. This combination, hunting perches paired with nesting platforms, created something close to a self-sustaining cycle. More successful nesting meant more raptors. More raptors meant more hunting pressure on rodent populations. Lower rodent populations meant healthier grassland with intact root systems and better water retention. Healthier grassland meant better conditions for livestock, which meant better outcomes for the herding communities who depend on this land for their entire livelihood. But the story doesn't end with just installing some poles and watching nature take its course. This program required careful, ongoing scientific monitoring to actually understand what was happening at an ecosystem level. Researchers tracked several key metrics over multiple years across different study regions. They measured rodent burrow density before and after pole installation. They tracked raptor population counts and nesting success rates. They monitored vegetation cover and root system health in treated versus untreated areas. They even tracked soil erosion rates, since one of the biggest long-term concerns wasn't just the rodents themselves, but the erosion and land degradation that followed once burrowing had stripped away root structures, holding the soil together. The data that came back over time was consistently positive. In treated regions, vegetation cover improved as rodent burrowing pressure decreased and root systems had a chance to recover and stabilize soil. Erosion rates slowed in areas where grassland had begun regenerating. Livestock injury rates from stepping into burrow holes decreased as fewer active burrow systems remained close to the surface in heavily grazed areas. And raptor populations, which had been critically low across much of this region for decades due to prior poisoning campaigns, began showing genuine recovery trends, season over season. This success didn't happen in isolation, either. It connected to a broader shift happening across Chinese environmental policy during this period. A move away from chemical-heavy, brute force interventions and toward what researchers call ecosystem-based management. The idea is straightforward. Instead of trying to fight nature with chemicals and force, you try to understand what natural balance used to exist in a given ecosystem, and then you find ways to restore that balance, rather than override it entirely. The perch pole program became something of a flagship example of this approach actually working in practice, not just in theory. It got cited in academic papers. It got studied by international ecologists interested in similar rodent management problems in grasslands elsewhere in the world. International interest in the program grew steadily as word spread through ecological research circles. Grassland degradation caused by burrowing rodents isn't unique to China. Similar problems have shown up in parts of Mongolia, in sections of the American Great Plains, and across grazing regions in Central Asia, wherever historical predator populations have been reduced through habitat change or direct persecution. Some pilot programs modeled directly on the Chinese approach have since been tested in parts of Mongolia, with early results suggesting the same basic principle. Giving raptors a place to perch produces similar benefits even when the specific rodent and raptor species involved are different. And the bottleneck here really was that simple. It wasn't that raptors couldn't hunt rodents effectively. Birds of prey have been doing exactly that for millions of years, long before humans ever showed up on these grasslands. The bottleneck was that human activity, specifically decades of habitat simplification and poisoning campaigns, had removed both the predators and the physical infrastructure they needed to hunt effectively. Once researchers understood that the missing piece wasn't more chemicals, but simply giving the birds somewhere to stand, the solution became almost embarrassingly simple in hindsight. Herders in the affected regions noticed the changes directly, too. Ranchers who had been dealing with collapsing burrow systems and injured livestock for years started reporting healthier pastureland in areas near the pole installations. Some communities became actively involved in the program, helping install and maintain poles across their grazing territories once they saw the direct benefit to their own livelihoods. This mattered a lot for the long-term sustainability of the program, because unlike a poisoning campaign that requires ongoing government funding and logistics to keep reapplying chemicals, a perch pole program benefits from local buy-in. Herders have a direct incentive to protect and maintain these structures because they can see the connection between healthy raptor populations and healthier grazing land for their own animals. Some herding families even began treating the poles with a kind of quiet reverence, keeping an eye on which poles seemed to attract the most raptor activity and reporting sightings of new nesting pairs to local wildlife officials. In a region where Tibetan Buddhist beliefs often emphasize respect for animal life and the interconnectedness of natural systems, the idea of working alongside a predator rather than against it resonated with values that were already deeply held in these communities long before any government program arrived to formalize the approach. There's also something worth noting about how this program handled the inevitable tension between conservation and practical land use. This wasn't a program designed purely around protecting an endangered bird species for its own sake, although raptor population recovery was absolutely part of the goal. It was designed around solving a practical, economic, and ecological problem for the herding communities who live on this land, using the recovery of a natural predator as the mechanism to do it. That framing mattered a lot for getting buy-in from local communities and regional governments, because it wasn't asking people to sacrifice their livelihoods for conservation. It was showing them that conservation and their livelihoods were actually the same goal, pointed in the same direction. As the program expanded across more provinces, researchers also started studying which specific raptor species responded best to different perch configurations, and how spacing and pole height affected hunting efficiency and territorial coverage. Different bird species have different hunting styles. Some prefer perch and pounce hunting from a stationary position, which made the wooden poles ideal. Others hunt more through soaring flight and scanning larger areas from above, which meant they benefited less directly from individual perches, but still gained from the overall increase in prey visibility across cleared, healthier grassland. This meant the program had to be tailored regionally, with different pole densities and configurations depending on which raptor species were present or being targeted for recovery in a given area. Over time, the program also revealed some unexpected secondary benefits that researchers hadn't fully anticipated at the outset. As rodent populations came under control and vegetation recovered, other grassland wildlife species began showing population improvements as well, since a healthier grassland ecosystem supports far more than just livestock and raptors. Insect populations, smaller bird species, and other native wildlife that depend on stable grassland vegetation all showed signs of recovery in areas where the perch pole program had been running longest. In a sense, restoring one predator-prey relationship at the top of the food chain sent ripple effects through the entire local ecosystem, strengthening biodiversity far beyond just the rodents and the raptors that hunt them. This is, in some ways, the quiet lesson buried inside this entire story. The rodent infestation across China's grasslands wasn't really a rodent problem at its root. It was a predator problem. The rats and pikas weren't doing anything unusual by exploding in population. They were simply responding to an ecosystem that had lost the natural checks that used to keep their numbers in balance. Once those checks were reintroduced, even through something as simple as a wooden pole stuck in the ground, the rest of the system started correcting itself without needing constant human intervention to force the outcome. That's a strikingly different philosophy than the poisoning campaigns that came before it. Poison requires continuous effort, continuous cost, and continuous risk of collateral ecological damage, and even then, it only produces a temporary win before the underlying imbalance reasserts itself. Restoring a natural predator population, once it reaches a self-sustaining level, requires almost no ongoing intervention at all. The birds hunt because that's what they do. The poles just give them a place to do it from. Today, across parts of the Tibetan Plateau and Inner Mongolia, you can drive for miles across grazing land and see these wooden poles dotting the landscape at regular intervals, often with a raptor perched right at the top, scanning the grass below for movement. It's become such a normalized part of the landscape in some regions that it barely draws attention anymore. Just another piece of grassland infrastructure alongside fences and livestock enclosures. But each one of those poles represents a small but deliberate intervention that helped reverse a rodent infestation crisis that chemical poisoning couldn't solve after years of trying. The story of China's grassland rodent crisis is ultimately a story about how the most effective solution to an ecological problem isn't always the most aggressive one. Sometimes the answer isn't more chemicals, more traps, or more direct human intervention. Sometimes the answer is stepping back, identifying what natural process used to keep a system in balance, and then finding the smallest possible way to restore that process. In this case, the smallest possible way turned out to be a few thousand wooden poles, planted across some of the most remote grassland in the world, giving an old predator a new place to stand. If you found this as fascinating as we did, there's a lot more happening across China's environmental and infrastructure projects that rarely makes it into Western headlines, and we cover stories like this regularly. If you want to see the next one, go ahead and subscribe so it shows up when it's ready.